sequences, starting with problem 7, 15, 29, and 35. So problem number 7 asks us to, given a sequence, determine if it's arithmetic or not. If so, find the common difference. Bearing in mind the common difference is typically talked about as D, in this case while we're adding or subtracting. Now looking at this, it might be easier to look at it in terms of decimals, because right now what we're looking at is 3, 5 halves, and so on. But if you look at this, this is also the same as saying 3, 2.5, 2, 1.5, 1, and so on. It's equivalent. This means what? Well, simply put, it means that the common difference, that is to go from one to the other, remember that would mean I take 2.5 minus 3 is, let's clean that up a little bit, 2.5 minus an actual 3, right, is equal to negative 0.5. This means it is definitely, and if you look at this, it continues, that same pattern continues. So this is arithmetic, so let's just write this, type this rather. This is arithmetic, and D is equal to negative 0.5, and that's it. Problem number 15 gives us an equation, right? A sub n equals 2 to the n plus n. Write the first 5 terms and determine if it's arithmetic or not. Now, I'm not going to insult your intelligence here, but what we're asked to do then is basically plug in for the first 5 terms, plug in the values. Now remember, it always starts at 1. So the first thing is going to be 2 to the first plus 1. I just plugged in 1 for both of the values of n, which then ends up being 2 plus 1, or 3. If you follow this to its logical end, then you end up with 3, and when you plug in 2, you get 6, 2 squared plus 2, then 11, 3 squared, or 9, or sorry, 2 cubed rather, which is 8 plus 3, which is 11. Then you do 2 to the 4th, which is 16 plus 4, or 20, and then 2 to the 5th, which is 32 plus 5, or 37. Now looking at this, the common differences are all different. In fact, all you have to do is look at this and say, oh, this is going up by 3. Here, this is going up by 5. Which means it is, in the end, not, let's underline that, not arithmetic. And that is it. So then, taking a look at problem number 29. 29 says, find the formula a sub n for the arithmetic sequence, and it gives you these 2 values. So, easiest way, we know that we have n and a sub n. Then what we're going to do is go ahead and I'm going to put those in a table. Now I've cunningly arranged this so if I started counting at 0, which is what I'm going to count, right? 0, 1, whoops, 2, 3, 4, 5, 6. Now for small values, I find this is the easiest way to go, because now what I can do is I can put in what the values are here. So this is 94, and this is 85. So what we need to remember is there's some sort of constant difference happening. Now, that constant difference is equal to the slope. Now, please bear in mind that if I'm looking at these 2 coordinates, that is 394 and 685, I could find the constant difference by simply finding the slope. Which means what? Well, y, or a sub n, so I'm going to go ahead and do 85 minus 94, change in the dependent, or the y, divided by the corresponding change, so it's important I have the 6 minus 3 here. And what this is going to tell us is how much this is going up by. Now remember, it tells us it's an arithmetic sequence, which is why we can get away with doing this. So 85 minus 94 is negative 9, which is not the common difference because 6 minus 3 is 3. The common difference between each value, from 0 to 1 to 2 to 3 to 4 to 5, is negative 3. Now, to write the arithmetic sequence, we want to have a sub 1 n equals. Now we know the common difference, and there's two ways to go here. Could I figure out what the first term is? Yes, there's a couple different ways to go. This is just a linear equation, right? So I've got 2 points, right? And I've got the slope now. So what I could do is go ahead and write out the slope. So I'd say negative 3, but instead of x, it's going to be n plus b, our y-intercept. 2 ways to go. I could work backwards in this table. So that would mean instead of subtracting 3 this way, right, I'd have to add 3 this way each time. Add 3. And if I did that, I'd have to go all the way to the y-intercept. So 97, I have to go all the way to 97, let's see, 97 here, 100, and then this would be 103, which would mean the final formula would be a sub n equals negative 3n plus 103. Now, if I wanted to just use the regular first term formula, that is a sub n equals a sub 1 plus n minus 1 quantity times d, then it would look a little bit different. The only difference is I would be starting at 100, which is the first term. I count backwards to get that, probably the easiest way to go, plus n minus 1. Remember that n minus 1 is a counter that gets us back to the original, times negative 3. How you write it, either way works. And then, for our last problem for this set, write the first 5 terms of the arithmetic sequence. Okay, a sub 8 equals 26, a sub 12 equals 42. I'm going to treat this like a what? Linear equation, because it's an arithmetic sequence. So I'm going to do 42 minus, I'm going to find the slope, 26 over, make sure you match things, 42 and 12 go together, so 12 minus 8. So 42 minus 26 is 16. 12 minus 8 is 4, which means that the common difference is 4. So there's a couple ways to go. You could count back to the first terms. You want to write back to the first 5 terms of this arithmetic sequence. So you could count back and then figure out what the first term is, that is when n equals 1. Or you could just go ahead and find that actual sequence, the formula for the sequence. There's a couple different ways to go. So let's just say, for argument's sake, we know that we have a linear equation, and let's say that we're going to say that 26, so what I'm doing is I'm plugging in that for a sub n. I want to figure out what a sub 1 is, so I'm going to go straight to the first term, just because that might be a little bit easier, which means, and then I'm going to be looking at the n minus 1 thing. But remember, instead of n, I'm going to put in 8, which is what the value is at that point, minus 1. And we know, that's a 1, believe it or not, times 4. So this is an equation that we could then solve, right? 26 equals a sub 1. I'm going to do 2 things at once. Don't blink too many times. 8 minus 1 is 7, times 4 is 28. And if you think about it, to go from the 8th term to the 7th term, that means I'd have to do what? Oops, I missed a sign here. Plus, there we go, plus. Because what I would have to do is, what? Subtract 28, which means that a sub 1 is equal to negative 2. Let's see. Yeah. So a sub 1 equals negative 2. Then that would mean that the next term would be 2. The next term would be 6. The next term would be 10. Then the next term would be 14. And that would be the fifth term. 1, 2, 3, 4, 5. The sixth term would be 18. The seventh term would be 22. And the eighth term would then be 26. So it fits in the pattern. And that is that.